Enjoy this place value warm-up song.
Picking pairs, I got 1, 2, 3, 4, 5, 6, 7, 8, 9. That's all that fit inside the ones place value line. So I picked another pair and made a group of 10 that fit into a bag perfectly even. 20, 30, 40, 50, 60, 70, 80, 90. I had to keep picking pairs of hunger I had to feed. So I picked another 10, and that led to one group of 100.
The pair bumped me on the head, and I said,
10 ones make 10. 10 groups of 10 are 100. 10 hundreds make 1,000. The pattern never ends. I rode my bike 1 whole mile, then 2, 3, 4, 5, 6, 7, 8, 9, and in a little while, another mile made one group of 10. A little voice inside my head said,
keep going, I know you can.
20, 30, 40, 50, 60, 70, 80, 90. I never knew I had so many miles inside me. The end of my trip was coming up ahead. I rode 10 more miles and reached 100.
Then that little voice inside my head said,
10 ones make 10. 10 groups of 10 are 100. 10 hundreds make 1,000. The pattern never ends. After the bell rang at 8 o'clock, I started playing with my base 10 blocks. I stacked up 9, and then one more made 10, and then 10 tens equal 100. 200, 300, 400, 500, 600, 700, 800, 900. Another 100 wouldn't fit in the 100 space. I had to write one group in the thousands place. Then I played the air bass. 10 ones make 10. 10 groups of 10 are 100. 10 hundreds make 1,000. The pattern never ends. 10 ones make 10. 10 groups of 10 are 100. 10 hundreds make 1,000. The pattern never ends. 10 groups of 1,000 equal 10,000. 10 10,000 make 100,000. And 10 of those make 1,000,000. And the pattern has no end.
We are learning to partition and group numbers using our knowledge of place value. Hi everyone, this is Mild Maths. Today we're going to be partitioning place value numbers using standard and non-standard partitioning skills. Now, non-standard may be something that you might not have heard of. So I'm going to show you an example of a standard and non-standard partitioning skill. So let's start with the number 10. We know to do this, we could use one long MAB block, which is a tens block. This is the standard way of making 10. It's the quick way, it's the most efficient. However, we could also make it in a non-standard way. Have a think, pause the video quickly here and have a think, how else could you make 10? Not using the standard way. Well, we could use 10 ones. This is the non-standard way. It's not as efficient as using one long MAB block. So this is 2 ways we could make 10 using our MAB blocks. Let's choose a different number. Let's choose 15. Have a quick think, what's the most efficient way, standard way, we could make the number 15 using our MAB blocks? We could use 1 10 and how many ones? And 5 ones. Let's show that in a table. We have 1 10 and 5 ones. What's a non-standard way we could make this number? Have a think. Could we use 2 10s? Would that number be too high if we use 2 10s? We could definitely use 1s. That also makes 15. Let's show that in a table. How many 10s do we have here? None. How many 1s? 15. So that's a non-standard way of partitioning our number. Alright, now we know what a non-standard and a standard way of partitioning our place value numbers are. Let's have a go at drawing it in a table. So what you need to do, you need to choose one number. Now I would choose a number that may be double digits, so 2 digits. So something that is a little bit higher than 10. I'm going to use 23 to start off with. We don't need a hundreds column because we're only using 2 digits. We're only going as high as 10. Now, our job today is to show this number using standard and non-standard partitioning skills. So the first one, let's start with our standard way because we know that's the easiest, most efficient way to make this number. So I would need 2 10s. How many 1s? 3. Now I can write it in my table. How many 10s did I have? 2. How many 1s? 3. What's our total number altogether? 23. Can we make it another way? Let's have a look. Alright, so this time, let's try and make it a non-standard way. So maybe a way that's not as efficient, but still equals the same. So, we have 2 in our 10s column. Last time we used 2 10s. What could we do differently this time? We could definitely just use 1 10. How many 1s would we need this time though? Imagine it in your head or plan it out with some counters or maybe some concrete material at your house. I'm going to imagine it and I'd need 10 1s just to make it another 20, wouldn't I? Okay, so now we have 20 altogether. I still need 3 more 1s. Alrighty, so I've made my number now. It might not have been efficient, but it still equals the same thing. But let's double check. How many 10s have I used? I've used 1 10 this time. How many 1s did I use? Let's count. 2, 4, 6, 8, 10, 11, 12, 13. So 13 1s this time. What's my number altogether? 1 10 and 13 1s. It's 23 still. Have we still got the same value? Yes, we do. Can we make it another way? Let's see. Alrighty, this time let's just make it completely out of 1s, because last time we used 2 10s and we've used 1 10 as well. Let's see if we can use all 1s to make this number. Okay, this time we used no 10s to make our number. How many 1s did we use? We've used 23 1s this time. So what's our number altogether? 23. Righty, here I've drawn my table up with the 3 different ways we made our number 23. Can you see any patterns here? Pause the video and see if you can see any different patterns forming. I can see some patterns forming in our 10s and 1s column. If I look here, the less 10s we use, the number goes down. So we started with 2 10s, we went to 1 10 and 0 10s. Over here, the less 10s we used or the more 1s we used, the number went up. 3, 13, 23. Can you see a pattern forming here as well? It always ends with 3. And the number in our 10s column is going up. We have 1 here and 2 here, and we would normally have a 0 here. Can you see the patterns forming here? Your task today is to choose a number and show the different ways you can partition that number using standard and non-standard ways of partitioning. How many standard ways did we figure out how to work out 23? That's right, we used 1 standard way. How many non-standard ways did we use to work out 23? Now remember, a non-standard way still equals the same number, but not as efficient. So not as quick. We use 2 non-standard. Your challenge today is to choose a 2-digit number and work out how many ways you can make it using MAB blocks. Draw them out just like I did and use a table just like this one to work out how many ways you can make your number. Remember, there may only be one standard way and a multiple different ways of non-standard ways of making your number. Have a think and use your number knowledge and your MAB knowledge to work out the place value of these numbers.